And welcome, Finding and Communicating the Story, Lesson 4 of 6, Working with Complex Data Streams. So we've had 3 previous lectures, an introduction and an overview. We looked at working with qualitative, then we looked at working with regular quantitative data, and today we're going to be looking at bigger data streams, larger sets of information, more complex sets of information. Then we have 2 more webinars in the series, utilising visualization, and finally bringing it all together in the presentation. So today, very brief recap, looking at what complex data is and its implications. Take an example from measuring social media, which is a really nice example of complex and large data. Some other instances and examples of working with big and complex data, and the strategies for finding the story in that information. So first of all, the recap. I'm a big fan, as those of you who have taken and followed the previous lessons will know, about the frameworks approach. The frameworks approach starts by defining the problem really clearly. There's a lovely quote here from David Smith's book on this topic. A problem fully defined is a problem half solved, and that is so true. Many times I see a piece of research conducted and what the agency or the insights manager have done is exactly what was asked of them, but they've not done exactly what was needed because the question was a little bit too vague, hadn't been pushed through, hadn't asked questions like, what does success like? Why are we running this research now? What actions do you plan to take once we have finished the research? Then we need to establish what is already known, what is believed and what the expectations are. This is going to help us understand all of the key things that we need to check because we want to validate or repudiate those expectations and those beliefs. And we also want to know whether our findings are good news or bad news. And to do that, we need to know what people's expectations were in the first place. Then we're going to organize the data in a systematic way so that we can do the checking and the procedures to find the information, apply systematic analysis, and finally extract and create the story. So that's a very quick recap. If you want to know more about the frameworks process, then lesson 1 in this series is probably the place to go first. So complex data, what do I mean by complex data? Well, traditional market research data look like this. We typically had 1 row per person. Most of the cells were filled in, they had data in them. So here we've got the ID in column 1, and then we've got question 1, which looks like it's numbers 1, 2, it could be red, green, blue, male, female. Question 2 is generating some sort of proper numbers. Question 3 looks like it's a multi-select type question. Question 4 looks like an open-ended question. And we ended up with these tables of data. Now, they could be very big, 20,000 rows, 30,000 rows, but the data was very samey. You took one person's data and it looked a lot like somebody else's data in terms of the structure. The content could differ, but the structure was very similar. Now, of course, qualitative data typically wasn't structured, but it was typically also very small because it's processed by hand by a human. It would tend to fit inside this bricolage bag, and we could sift through it and we could organize it. But those 2 things are no longer true. What we now have is a much more complex data picture, where some people generate only a little bit of data. Some people generate lots and lots of data. Some of the data they generate will be transactional data, so it will be a lot like rows and tables. But for somebody else, it's going to be video and pictures and comments, tags. Sometimes they will tag a lot of people. And when we have a lot of people tagged, then we have much more complex interactions within the data. When we have discussions between people, we have all sorts of interactions, and it's not a clear case where you can put that into a table or a structure. And we're seeing the growth of new tools like Ruby on Rails as the method of accessing some of that information, new data structures like JSON. We need to get with the new program to understand the complexities of these data, because the tools we've used in the past, which were basically around matrices, rectangular matrices, where most of the cells had data in them, are out of date. Now we do not have matrices, we don't have rectangles, and sparsity is the name of the game. For most people, we don't have much of the information. We have different information for each person. So we've got to start assembling this information. And one of the first questions is granularity. Is it at the individual level or the household level? So if you take something like gas consumption, electricity consumption, then that is going to typically be at the household level. If we're going to take other activities, so if we think about the history of retail information, it used to be at the store level. We used to know what a store took in and what a store sold. Now we know a lot of that information at the individual level because of credit card information, because of loyalty card information. The granularity has changed. The granularity of information about products has changed. So lots and lots of changes in the granularity. But if we have multiple data streams, they won't always come with the same level of granularity. We need to look at data streams and say, well, are they additive, complementary, duplicative, or what? So additive, let's say I'm trying to create a weather forecasting system. So I look out of my window, that's one piece of data. Now I have a friend in another part of the country who's going to look out of their window too. That's great. Now we have two pieces of information. Complementary, maybe we start having thermometers and rain gauges in our gardens as well. So this is adding to the picture. Now I start looking out of the window on the other side of my building. That's effectively duplication. It's very unusual for the weather to be different on both sides of the building. So when we're looking at income, we might be interested in knowing whether or not that information is duplicative. So how much does somebody spend? How much do they earn? How much do they save? It can be complementary, but it can also be duplicative. So all the time when we're looking at data, and in social media, this is a particularly key point, is that data going to be duplicative, complementary, or additive? We need to look at what we're not measuring. So loyalty card data is a really good example. We get masses and masses and masses of data about some customers and very little data about other customers. Maybe we have mobile phone data about people who are on contract, but not the people who are pay-as-you-go. So all the time when we're looking at this data, we need to think about what is being missed, because in some of these cases, I've seen people come along and say, we've got 20 million people's worth of data. We've got every phone call they make, every movement they make. We know where they are geographically all the time. But it's only the contract people. We don't have it for the pay-as-you-go. And there are enormous behavioral and social differences between the contract people and the pay-as-you-go. So we need to be looking at what is missed in the data. What about lags in availability? Some information is coming along in real time. Other information comes along quite quickly. Other information much slower. So we're trying to do a tracking project looking at TV, posters, online, and so on. Some of that online data is going to come in real time. Some of that TV data will come in real time, but the traditional tracking component where a survey is completed and the information comes back, it might be 6 weeks before that is useful information. If we need financial information, let's say we're trying to map NPS and lots of other data to financial performance. The financial performance of a company is typically 1.5 to 2.5 years in arrears. So we have most enormous time lags in some of that information, and we need to factor that in when we're working with these complex data streams. We've got to normalize the data because it will come in very different ways and shapes and forms. If we're trying to look at rainfall compared with temperature, compared with air pressure, compared with humidity, all of these are on different scales. So we're going to bring those scales together. So we've got shopping data, number of items, value of items, all of these sort of different issues, number of shopping trips, all of these sorts of issues, bring them in onto some sort of common scale. And most things that we look at in research only have a relative value. 1 million people visited this site. 100,000 people marched in the street. The new trial for this product was 6.5 million. All really interesting numbers, but they don't mean anything unless we know what the normal figures are and what the top decile is and what the bottom decile is. So we need to find comparators for our information to make it make sense. Once we've done that, what we're typically looking to do is create a model of the interactions, because if we have multiple data streams, they will interact in multiple ways. We need to work out how do we combine that information so it is meaningful. Which parts of the data are drivers and which parts of the data are consequences. Here are a few examples of data streams. So the ones on the left are fairly typical of the market research world. But on the right, we might also be looking at what is being said in the news, professional reviews, some mystery shopping feedback, all the letters, calls and emails from customers, the transactional information, third-party information, enterprise feedback. So there is no limit to the number of different sorts of information that can be gathered. Looking at some of those characteristics, timelines, is it monthly data, weekly data, daily, continuous? Coverage, who is represented and who is missed? Richness, are we getting a single number or a range of measures, or are we getting quotes and open-ended so we know what people bought and maybe we've got a satisfaction score from them, but if we also got why they were satisfied or why they were not satisfied as an open-ended comment, all of that is to do with the richness of the information. The veracity, how honest and accurate and persistent is that measure? So honest is a fairly straightforward concept. Did people fib? How often do you cheat on your partner? Doesn't generate incredibly honest information. How many cups of coffee have you drunk in the last month? Doesn't generate particularly accurate information. If I ask you how much would you pay for a cup of coffee, you might give me a number. But then let's say you've gone to the airport, you're really gasping for a coffee, there's a while yet to go before your plane leaves. Now you're probably willing to pay more. So a lot of our views and beliefs don't persist for very long. So when we're looking at data about its veracity, it's not just honesty, it's not just accuracy, but it's also persistence. Is this a characteristic which is true of somebody for a considerable period of time, like where do you live, where do you work, family size, or is it something that changes during the day as we move through our lives? And then depth. Do we have one measure per person or many measures? So here's a great example of somebody who was doing all of that and producing some very interesting results. So Nate Silver, who runs a website called 538, and if you're interested in American politics, I'd highly recommend it. He's also written a fantastic book, The Signal and the Noise, and it looks at big data and it shows when big data works and it shows when big data doesn't work and why it doesn't work. So for example, big data is really good now at forecasting the weather. The weather forecast for the next 7 to 8 days is pretty good. It's got a lot better over the last few years. However, the forecast for earthquakes has not improved since they started trying to come up with models. And there is good theoretical evidence and academic thinking, philosophical thinking, that says we might never be able to predict earthquakes because of the nature of the actions and the components. So he looks at all of these issues in this book and highlights when we would expect big data to be useful and when we wouldn't. And he's a big user of data. So he does a lot of work with election predictions, and he came to fame 8 years ago by being really good at the US elections, and then got it right again 4 years ago. So let's see how he does on the next election, which is probably the Clinton-Trump election, but I guess it might not be. We'll see how that goes. But he doesn't collect polling data of his own, doesn't pay for polling data. He uses publishers' data from other people. He's a data aggregator. It's a very inclusive approach. So he looks at the data generated by other people, and he weights it by how recent is it. He weights it by the sample size. So if we have two equally good samples, but one of them is 2,000 and one of them is 1,000, he would give a higher weight to the 2,000. Pollster rating. Some pollsters have a better track record, so he will give them a higher weighting than the less good ones. Some pollsters tend to be more pro-Republican, some tend to be more pro-Democrat. In the UK, we have exactly the same phenomenon. Some pollsters tend to be more Labour, not because they're biased in the sense of wanting the data to be more Labour or wanting the data to be more Republican, but simply because their methodology tends to favour that way round. One of the key factors in most countries, but not Australia, who voted just a few days ago, is the likely voter adjustment. If voting is not compulsory, then one of the hardest things for the pollsters to do is to make an assessment of how likely it is that people will vote. So he is looking at all of these factors from these different sample sizes. Then he does a trend line adjustment. Have they tended to be accurate or not, the pollsters? He looks at things like congressional approval. And then when I first saw this, I slapped my hand on my forehead. Why would polling companies, the famous polling companies, the Gallups, the YouGovs, and all of these, focus on polling data alone when you could put in things like fundraising totals? Of course, that is adding complementary information, a much richer picture when you're trying to forecast the result. What is the highest elected office held? Because there is a tendency for people who've held office to do better, partly because they have a better ground game, as it's called. So getting out the vote, people who are knocking on doors, people who are giving people lifts to the voting stations. Margin of win in the most recent research, are they competitive politicians? Ideology and state leaning. So in the South, you're more likely to see a Tea Party candidate do well. In the Northeast, we're more likely to see Liberals doing well in the United States. So all of these factors he's taking into account to make a compound prediction. And when he makes predictions, he doesn't do the classic thing that polling companies do, which is that we think Party A will get 35%, Party B will get 33%, Party C will get the rest. He actually focused on what's the probability of winning. And if you think about what I said earlier about defining the problem, most of the time when we look at elections, we actually want to know who's going to win. We're less interested in how many votes they're going to get. Rather, we're interested in whether they're going to win. So all of 538 and Nate Silver's predictions are based around this. I think that this candidate has this probability of winning, this candidate has this probability of winning. And that's a really interesting way of doing it and something that we could probably do a lot more of. For example, if we do a concept test, maybe rather than saying that we think this will get this many sales, this many sales, and this many sales, put a probability of this one being the highest, the next probability, and so on. Now, once Nate Silver has gathered this sort of predictive tool, he doesn't see himself as a political poller, he sees himself as a predictor. Consequently, he uses his techniques to predict sports results, basketball, baseball, and so on. He's even used it to predict Oscar results. So to some extent, we've got ourselves in the market research insights world into a silo where we think we use market research to make predictions about market sales. Actually, we should often think of ourselves as data modelers who make predictive models using predictive analytics, and that gives us a much wider canvas to work with. So I'm just going to take a few examples now from a project I worked on last year with the IPA Social Works. So the IPA Social Works was a joint operation of the UK's Market Research Society, the IPA, who are the people who make the adverts, and the Marketing Society, who are the people who pay for the adverts and run them. And it was sponsored by Twitter and Facebook. So we were looking at how you can measure the ROI from social media campaigns. And there are a lot of complexities in this area. This is the sort of complex data stream I was talking about. We use a POEM framework. Now, what is the POEM framework? Paid media. So traditional TV, online display, direct mail is paid, paid advertising, AdWords in Google are paid search. All of this is paid. You get what you pay for. The next part of the POEM framework is the O for owned media. So one example of owned media are house magazines that the airlines have, for example, that a lot of fashion houses would have. They're also your website, they're also your Facebook page. All of these are owned media. You can determine what goes on those. And the final, the E in the poem framework, was earned media. This was supposed to be the holy grail, so to speak, of the whole social media world. People would upload media for free, they would retweet it, they would share it, they would add comments on it. So we have three fundamentally different pieces, and they interact together in complex ways, as you can see on this chart, and they're paid for in different ways, and they're measured. So paid for media, you know what you pay for it, and then you measure its observation in lots of different ways. For an AdWord, you know how many people saw it, and you know how many people clicked. For a poster board, it's much harder to work out how many people saw it and what action it had. Then we move into the actions here. So WOM, that's word of mouth. So all that paid advertising is going to interact with word of mouth and natural search, which are actually the earned media. It's the same as earned media, word of mouth and natural search. Then we have the owned media, stuff that's on your site. Then we have the classic social media that's earned media and sales. So we've got to try to unpick all of the pieces that are going on there. Some of the challenges. We have a counterfactual. You run a campaign and the sales go up, but would they have gone up anyway? If you didn't do that Facebook part, what would the sales have been? It's very hard to work out the counterfactual unless you do good experiments and A/B testing. Influence. Sometimes you'll find people telling you the way to do marketing is you've got to target the influencers. 10% of people tell the rest of us what to do. If that's the case, how are we going to measure our impact on the influence? Other people say, no, it's mostly about this thing called homophily, which is birds of a feather flock together. We do what people like us do, and we congregate together. So overweight people don't cause each other to be overweight, they gather together. Skinny people don't cause each other to be skinny, they gather together. That has really big implications. If a market is influence market, then you need to target your promotions and campaigns at the influencers. If your market is a homophily type market, you need to target your marketing at people like the people who've already bought you. So quite different strategies. And we need to look at short and long-term effects. And of course, we have the classic one of causation and correlation. So here's what I mean by the influence of homophily. If we think about a type of market, if it's an influence market, so it's a new type of shoe, the Croc shoes coming along, then what we're going to do is target it one way. But if it's homophily, so it's people in the neighborhood start doing this, they all start gathering the same sort of subscriptions and driving the same sorts of cars, then we've got the difference between targeting influencers in the influencer market and targeting people who are already like the people who are buying it. Short and long-term effects is a real challenge, particularly in the social media area, because social is really good at measuring short-term effects. How many people saw it, how many people clicked on it, how many people bought it after they clicked on it. Micro objectives are often activation events, so we might be interested and have targets about how many people are going to download it, how many people are going to register, how many people will play the game, how many will trial it, how many will purchase. Long-term effects, however, are more important. What does it do to the brand value and the price elasticity? Can you sell more stuff at the same price? Can you put the price up and sell the same amount of stuff? And we get this interaction going on because without short-term effects, if nobody does anything in the short term, there usually isn't a long term. But the long term is not the sum of the short-term effects. You can't simply add up how many people clicked on it to work out what the impact on the brand value was. Here are the sorts of approaches, and these are by and large in the province of the advanced analytics company, the gain theories, the bottom line analytics. So they're looking at market mix modeling, Granger causality, vector auto regression, a lot of specialist tools in there. There is some market research down the bottom end, pragmatic measuring, using social market research to evaluate social and social media research, but a lot of highly technical stuff in this area too. Here's a great example from the IPA Social Works report from a study done by Bottom Line Analytics. And this is a structural equation model that's showing the impact of many forms of advertising on personal care sales. So social is in there, but so is in-store, so is print, so is out of home, which is poster. Up at the top, we have those blue sections, which is market research in the classical sense. And all of that data has had to be normalized, brought together, and then put into the structural equation model in order to be able to give numbers to the impact of each of the different parts of that campaign. And this is just going to highlight the sort of challenge we need to be thinking about as soon as we get into complex data streams. Imagine that we're running a campaign in two parts of the country, the north and the south, or region A, as I like to call it, and region B. And in region 1, in time period 1, let's call that January, sales have been indexed at 100. In time period 2, February, we do some TV advertising, the sales go up to 110. So we think, right, sales have gone up 10% because of TV. And then in time period 3 in March, we run TV and Twitter and the sales go up to 130. So what has Twitter added to that picture? Well, it looks like it's added 20 percentage points. However, luckily, we were doing an experiment. So in region B, we still indexed in the first month on 100. In the second month, we ran just a Twitter campaign and sales went up to 110. And in the third period, we ran a TV and Twitter campaign and the sales went up to 130. So now we see that it's the compound effect of TV and Twitter that takes you to 130. It doesn't matter which one you do first. And you can't say that sales are worth 20 percentage points. You can't say that Twitter is worth 20 percentage points. But you could only see this sort of complex interaction if you design experiments in your campaigns and if you collect the right sort of information and if you then look for and measure the effects. So some lessons from measuring social which apply to everything. 1, plan in advance, define the objectives and bake measurement into the campaign. So you're going to do a complex set of activities, of in-store trials. We're going to change the layout of the store. We're going to do some TV advertising. We're going to do some retraining of the staff. You've got to decide what scores should be, what things are going to change in advance, and then put measurement into place. For a lot of these things, that means the granularity matters. You've got to have daily information for some things, weekly information for other things is okay. Focus on a core set of relevant metrics. There's a great book by Stephen Rappaport on digital metrics for the moment. It's got 197 different metrics. If you don't pin your client down, if you don't pin the team down to say what should change, if you wait till afterwards, they will find something in 197 metrics has gone the right way. It's really important to start off with 4, 5, 6 metrics that you say, these are the key ones that we're going to measure. We predict that success means this change and failure means this change. And those are the ones that you're going to work with. Try to include experiments or experimental designs. So don't run your campaign the same everywhere in the country. Try to start with different components and different elements, turn the services on and off. If you're rolling out a new handset, try to roll it out into different parts of the country and then interleave that with some changes in staff training so that you could have a much better chance of measuring those impacts. And have access to advanced analytics, but you still need to be pragmatic. You can follow the rabbit down the hole too far sometimes. In some projects, you'll see that 5% of the total advertising budget has been spent on advanced analytics. Occasionally that's worthwhile. Usually you're going to have to be more pragmatic and make a few assumptions. And okay, if we run the Facebook campaign and the sales go up, we can't prove causality. Sometimes we will just have to accept it and we will look for whether we get a repeat action the next time. Spoken about four big data, and if you talk about big data, you really need to be aware of IBM's 4Vs. So volume is the first one. It's the sheer quantity of information that has fundamentally changed. We are getting, megabytes, megabucks, terabytes, petabytes. It's getting bigger and bigger and bigger. Velocity is that information is moving faster, it's coming along faster, which means people want to make decisions faster. The whole concept of real-time telemetry, measurements and so on is meaning that we've got more data and the data is moving faster. Variety talks about the fact that it's no longer in those matrices. It's not just noughts and ones, it's not just numbers and words, it's pictures, it's video, it's a wide variety of interactions. And then veracity. How accurate is that information? Does it include everybody? Are people fibbing? If we think about one of the most important components in any large organization in terms of establishing the cost base is the timesheet. If timesheets are not accurate, then the accounts for most companies are not that accurate either. And just think about your own experience with timesheets. How accurate were they? Very often people will make sure that everybody has filled in timesheets, and that's one sort of accuracy. But actually the veracity is what they've put on those timesheets. What have they said in Facebook? What have they put on that survey form, and so on. If you're listening to this recording or this broadcast, you are probably not going to be doing the data science yourself. Data science is something that is really technical, and most of us work with data scientists. We work with people who can use R and this language here called Hadoop. So Hadoop is the language which underpins big data. And big data means it cannot be stored on one server. It's stored across lots of servers, across the cloud, multiple locations. And the great strength of Hadoop in the hands of a good analyst is they create an instruction. It goes to these multiple data sources. It extracts the right information from each of them. It combines those together and sends us the results. And the real power in working with these data analysts is in asking the right questions, really precise, useful questions. So one of the famous ones that people talk about is Target. Father goes into a Target store, he's really angry because his daughter, who is 16, has been sent some baby milk coupons, and says, my daughter doesn't even go out with boys, of course she's not pregnant. Comes back a week later to apologize. It turns out she is pregnant. How did Target know before her father that she was pregnant? And the answer is, and there's quite a good read up, you can go online and follow the whole story through. Somebody asked the data scientist at Target, could we find this information out? They looked to see that there are purchase pattern changes. Obviously Sampro would be one, but changes towards unfragrance products and more natural products are a probabilistic indicator that a woman within a certain age group is going to be pregnant. That's an example of a really tight, straightforward question. How can we tell from somebody's purchase behavior that they're pregnant? So here are some other big data successes, and there's a nice webinar from Annie Pettit on this topic in our NewMR festival from earlier in the year. If you go online to past events, you'll be able to get the whole show from Annie. Netflix, what sort of new productions should work? So nice straightforward question, going through the data that helped them invest in House of Cards. UPS, how can we optimize our routes? eBay, how do we identify fraudulent behavior? Weather Signal, how can we use smartphones to get a more comprehensive weather picture, a more localized map? And Stockholm's trains, what events cause delays on the train and how can we spot these? So in all of these cases, what they have in common is a nice, clear question. What you can't do with big data is say, is there anything interesting in there? Because nearly everything you will find will be bogus. The more data you have, the more spurious correlations there are in that information. So You really need these very tight questions that are going to generate useful outcomes. So, narrow question, patterned fraudulent activity. What events predict churn is a good way of looking at big data. How many types of customers do we have? So feeding that information into a segmentation is a great way of doing it. And if you look at the literature, you'll find a lot by Tesco on this and the work they've done with their loyalty card data to generate really powerful segmentations. Just going back to correlation and causation. Correlation predicts the past. Just let that phrase sink in for a moment. Correlation predicts the past. And sometimes that is enough when the past repeats itself. So around July the 4th in the United States, we have a pattern of purchase which is quite different from most of the rest of the year. We have very few people going to work that day. Now, even if we didn't know the meaning of July the 4th, we could work that out from the data that this pattern happened and this pattern repeats itself. So that would be an example of where pattern was really useful. Where correlation doesn't work is when things are new. So if we take the election coming up in the United States, most things around Trump and that election are going to be quite new. Correlations about this state voting this way means this indicator at this stage, this endorsement at this stage, this amount of money at this stage are all going to be shaky predictors this time round because this election is not like the past. So correlations can be really powerful, but they predict the past, not the future. To predict the future, we need causation, but that is really hard to establish in the real world. Very, very hard to establish in the real world. The key to establishing it are creating experiments. We obviously have some common sense around that too, but you need to create an experiment. So we launch product A this way in this region, and this way in this region, and this way in this region. A/B testing, where you do things different ways, is a good way at getting at causation, particularly if every other factor is held constant. And so one factor is allowed to vary. But as soon as you allow multiple factors to vary, measuring the causation is quite difficult, and there's quite a specialist area in approximating to that process. So as a little bit of a reminder, here is a fun diagram that somebody produced a couple of years ago now, looking at, on the vertical axis, Nobel laureates per 10 million of population. And this was published just after some papers came out saying chocolate is good for your brain, because along the bottom axis, we've got kilograms per year per head of population of chocolate consumption. And Switzerland has got really high chocolate consumption, and it's got really high Nobel Prizes per head of population. By contrast, China has very low chocolate consumption and very few Nobel Prizes. Now, if you got that with traditional market research data, you would really feel in your gut that this was meaningful. It's not, partly because of the countries that are not on the chart. So there's been a little bit of selection bias, but mostly what they're saying is that chocolate consumption in 2012 can predict the Nobel Prizes you won all the way back to 1900, because the Nobel Prizes, to get sufficient data there, go all the way back to 1900. So actually we have something going on which is quite different, which is the extent to which you play that Western game, which feeds through to Nobel Prizes, and it also feeds through to chocolate consumption. But it really, at first glance, looks awfully plausible. So one of the things we need to do when we're doing these complex data streams is try to work on what the counterfactual is. Now, how can we do that? Well, get your client to make projections and forecasts before the project starts. Look at year-on-year figures. Do a variety of normalizations. A/B tests, where things are tested comparatively, will all help. Making those predictions. So we avoid the risk of post hoc reasoning. Particularly when you've got lots and lots of data, you can always go back and find some cases which look really good. We're going to use triangulation to go back and find that information as well. So I'm using multiple sources to see if they point the same way. It helps validate the findings. It can certainly help you avoid making embarrassing mistakes. And it can also be used with predictions, this triangulation. So rather than just describing patterns, we can say, if this finding about a decline in satisfaction is true, we expect churn to increase over the next 3 months. So let's use that triangulation. Let's be braver. Let's make predictions that can be tested. When we're trying to understand the data, we need to use benchmarks. So few metrics have got an absolute meaning. The relevance of 1 million views or shares changes over time. It might be good this year and average next year. So we need to benchmark. We want within brand benchmarks. We want within platform benchmarks. So within store would be one type of benchmark. Online would be another benchmark. Within the vertical, so for pharma, is this a good score or a bad score? For auto, is this a good score or a bad score? And then within the target group. So when we're appealing to millennials, is this a good score or a bad score? Highlight benchmarks really bring back to the point about comparators. I'm going to show you a bit more about comparators in a moment. So we've organized that complex data, defined the problem, assess the characteristics of the data stream, the veracity, the granularity, etc. Filter, clean and transform the data so it makes sense. And then we're looking to find the answer. Again, as in the previous sessions that I've run, it's find the main story first, then the relevant exceptions. Simplify the models. Don't use really complex models to explain the data. And to borrow and corrupt Einstein's words, simplify the models as much as possible, but no further. Use comparators, and then we create that compelling story. So what I mean by filtering the data, here's the answer to the problems of the universe, the main question in the universe. We can't see it, so we start to filter the answers. It starts to emerge. Now we can remove the non-relevant answers. We see the answer is 42. That's the sort of paradigm that we're following. Here is a great example from Forbes of how they normalize some data by growth patterns. This shows over the first 4 years how many new users did they have, and we can see WhatsApp outstripping everybody else by a mile. That's why it was so valuable. That's why Facebook bought it. Google do a lot of work with Google Trends, where you can search what people are putting into their search strings to find out how relevant something is. But of course, every day more people are using the internet, and they're using Google in different ways. So what they do is they find out the share of searches every day. The highest single search is set to 100, and everything else is normalized off that. So here's an example. I said Zika, which is obviously of interest at the moment with the Rio Olympics. How many people have been searching for Zika? And we can see that there was quite a spike. And I can see that there wasn't a spike before February. But how big is that spike? If I want to do that, what I then do is I bring in some comparators. So I've got cancer, the green line, always a matter of real interest. And this spike in Zika has reached that. If we look at Ebola from July, October last year, we can see that was a much, much bigger spike than Zika. So now we start to see things, and then we get Middle Eastern respiratory syndrome as relative bumps. We need to create these comparators if we're going to make any sense of the number. We can also normalize by coding. So if we've got open-ended comments, we can convert them into positive, negative, and neutral. We can digitize information. We can allocate people to segments, like how many of our customers are heavy, regular, or occasional customers. How many are male or female? How many are satisfied, highly satisfied? How many are promoters, detractors? All of these are methods of normalizing sets of data by coding them. We can score them in different ways, in the way that American football has different scores or rugby has different scores. All of these can be used when we have incompatible types of information and we need to bring them together. There's a great example. This is a video that I'd recommend, Ben Wellington, talking about different public data sources. And one of the ones he talks about is a map he's created about fire hydrants. These are the fire hydrants that generate fines for cars parking near them in New York. And he can make some observations straight away. So parking in the Upper East Side is a bad idea, because you can see there are lots and lots of red circles. That means there are lots and lots and lots of places where you will get a parking fine. But down near the bottom of the map, there are two really large circles. And he wants to know, why were they generating over $50,000 a year in parking fines? So he went there and he looked at the layout, and he could see that it was a highly deceptive bit of road layout. It looked like you should be able to park there. You couldn't. And that is a great example of how we need to combine market research and big data, or qualitative information and big data, because to find out why those tickets were being generated, he had to go there and look at it as a human and interpret what people were doing and why people were parking there. And when he did that, he put it on his blog, and actually the city changed the marking on the street and the problem went away. But that's a great example, and I really recommend that short video. It's a short TED video, Ben Wellington. Have a look at it and you'll see how a precise question led to a clear answer, led to the need to identify why it was happening, which led to a qualitative piece of research. When we look at the information, we must use the business question as a lens, because the same data will deliver different stories based on different business assumptions. This is one of the reasons why an industry report, and I'm working on 2 industry reports at the moment, have a less focused story, because they have multiple readers with multiple needs. The business question defines what should be in your report, what the key questions are, where the magnification should be. So you're going to find the relevant story in your information, and then you're going to say, are there people who have a different story, different from this main story? Who are those people? What is their story? Where are the differences? Why are they different? When do these differences come into play? A journalism 5 W's: who, what, where, why, and when are what we look at for those people who have a different story. We need to look at different perspectives. So for some of you, that will be a duck looking to the left. For some of you, it will be a rabbit looking to the right. When we do that analysis, we need to find both of them. So I'll come back to this point about a comparator. If I want to show you how big an RFID is, well, there's a finger and there's an RFID next to it. Now you have some sense of the comparator. This is a great piece of work by Eurostat. It's been in one of our previous ones, so I won't pause over it too long. But several things. The first is the big data they've been working with here. They've had to clean this data about meanable deaths, deaths that could have been avoided, because they will be collected slightly differently in every country. So they've gone through and they've normalized that information. The next thing that's happened is that they've created a comparison by ranking the data from worst case to least worst. So of the 28 countries in the EU, France has the lowest number of amenable deaths. Latvia has the highest number of amenable deaths. So ranking is a really key comparative tool. The next thing they've done is they've split male from female. And we can see that for a large part of the chart, in the more developed parts of Europe, the line between yellow for men and women in blue is quite small. In every single case, it's worse to be a man than a woman in terms of avoidable death. But by the time we get to Poland and then through Czech Republic, Croatia, it really grows. And the key thing you can often tell is if you've got a good set of comparisons, you don't need numbers. There are some sort of numbers on the left-hand side of this page, but the whole story is told by the ranking, the yellow dots and the blue dots, and the way they're organized. So finally, the big picture. It starts with a well-defined question. The more complex the data, the less chance you've got of finding the right answer without having this really clear question. Assess the data streams. Who, what is covered, the lags, the duplication, the veracity, etc. Bake measurement in from the start when possible and make specific predictions about what you think is going to happen. Transform, filter, clean the data. Find the main story. considering correlation, causation, the comparators, alternative models, influence and homophily, and so on. Once you've found the main story, then let's use our 5 W's and find the relevant exceptions. And the exceptions are cases where a different business recommendation comes out of it. An exception is not something like young men are slightly more likely to do this, if in fact we would still make the same business recommendation. An exception is where we would make a different business recommendation. So thank you very much. Please follow me. Think about the mailing. The next of these lectures is on September the 13th. So I hope you'll be able to join us for that, where we're going to look at visualization. Visualization to find the information and find the story, and visualization to communicate the story, because they're quite different between the two. So with that, I'd like to throw it open to questions, and thank you all for